Good afternoon, students.
Good afternoon, ma'am.
Good afternoon.
Okay. So I just asked here, like how are we supposed to conduct? Okay. So question paper pattern is still not given. Like I have to conduct the question paper pattern. As I told you in the morning, do not worry about the exams. I look into your convenience and I will create a question paper. Now they told me to do only 10 experiments. Okay. So out of 17, we are only doing 10. In that 10, 3 are demo experiments. Please make a note of it. 3 experiments are demo experiments. Experiment number 3, experiment number 6, and experiment number 10. These 3 are demo experiments. And the rest are all performing experiments. That is 1, 2, 4. 1, 2, 4, 5, 7, 8, 9. Okay, I think so. It's good for you right now. You can do it. 10 experiments can be done. Yes or no?
Madam, demo 3, 6 and 10.
Yeah, demo 3, 6, and 10. And performing experiments are the remaining. It is going in the same order as present in your manual guides, 1 to 10.
Yes, ma'am.
All right.
Ma'am, any confirmation about the dates as we have to book the tickets?
Okay, so when I spoke to them, they actually told me that today and tomorrow will be for your paper number 12. Okay, and next week, that is 20th, 21st, I don't know. Next week, Saturday, Sunday will be for your paper number 13. And then 27th and 28th will be your test, your exam. Yeah. As per the information given to me, they told me to finish paper number 12 today and tomorrow. Paper number 13 will be done next week, that is Saturday and Sunday. Paper number 14, sorry, not 14, sorry. Exam will be the coming, the other week, that is 27th, 28th will be the practical exam.
Ma'am.
But here what I'm doing is, since we are only keeping 10 experiments, 5 experiments are done in the morning. The remaining 5 are all same. They're all volumetric analysis, that is titration has to be done. So once you know the procedure, it is easy for you to do the titrations. So remaining 3 experiments are pending now, 7, 8 and 9, which are titrations. We'll finish those 3 experiments. If I finish these 3 experiments, including your demo experiments, we'll be having 10 experiments in your record book. Clear?
Yes, ma'am.
Okay. And the next thing is tomorrow morning, the morning session from 9 o'clock, I'll start with paper number 13's experiments. Okay. Paper number 13, we have 20 experiments to be done. One minute. Okay. Okay, paper number 13 have 20 experiment. So there also they told me to reduce the number. So if I put 15, is it okay?
Ma'am, make that one also 10, ma'am.
That one also 10 you want?
Yes,
Yes,
ma'am.
ma'am.
10. Yes, ma'am.
Ma'am, yes, we have less time now, that's why.
Yes, ma'am.
Okay, fine. So paper number 13 also we'll do 10. All right. So tomorrow morning session we'll try and finish first 5 experiments. Tomorrow's afternoon session I am not taking class. Clear? It's a good news for you all because I
No,
have
ma'am.
some other work to be done. So tomorrow's afternoon session I'll not be taking class. The remaining 5 experiments will be done in the coming week Saturday class, Saturday afternoon session. Because Saturday morning session I'll be having my regular classes. If I get time, I'll tell Shafaka sir to put a message for you all to join in the morning only. Otherwise, Saturday afternoon definitely we'll be finishing those remaining 5 experiments. Sunday again you will have no work. You can finish all your work, everything on that particular Sunday. Then 27th you can come down for the practical. Clear?
Ma'am,
27th is
on
confirmed, ma'am.
27th, 28th, we will be having UPSC prelims examination.
27th you'll be having what?
28th, we
Sir,
will be having.
Ma'am, on 28th we have UPSC exam.
27, 28.
28th, Sunday, ma'am.
Ma'am,
So you
on
got to come for the exam.
28th we have prelims,
Please,
ma'am. No, ma'am,
So you
we
cannot
can't
come
come
for
for
this
exam
exam.
on 27th. No, ma'am.
Okay.
Please complete the exams on the 20 and 21st,
20
ma'am.
and 21st.
Yes, ma'am.
But that day class, no?
It will be very helpful for us.
20 and 21st we have counseling, ma'am, for the exams.
See, you decide among yourself when is the proper day, because some of you are not free on 28th, some of them you are taking an exam on 27th. So you decide among yourself and tell me. Okay, please message me. You must be having my number, my WhatsApp number. Please message me so that I can forward it to them.
Ma'am, maximum was already on 20 and 21st, ma'am.
28th and 21st is fine for everybody.
Yes, ma'am. Maximum of us we
Yes,
are ready.
yes, madam. Yes, madam. Yes, madam.
See, you decide among yourself and let me know. Then I'll tell them.
Yes, ma'am. We have decided, ma'am. 20 and 21st we are ready.
Ma'am,
Okay, 20 and 21st, I'll tell them. Fine.
Okay,
20
madam.
and 21st, I'll tell them. Then you can prepare and come for 20th and 21st instead of 27th.
And
So,
ma'am, can it be afterwards, after 28th? Next week, after 28th?
No, ma'am. Please,
June's first week, are you all free?
it will be very late, ma'am, because we are 2021 January students. It will be
That
3
is
years
what I'm
for us.
telling. You decide among yourself and then
These
tell.
people are July 2022 people. It will be okay for them.
But result will be on the same date, right?
And I'll put forward this message to them. They will let you know. Okay. Seventh experiment. Determination of seventh experiment. Please mute yourself, Deependra. Determination of acidity in water. Determination of acidity in water. So acidity means it is clearly understood by the name of the experiment only. You are seeing the acid content. And experiment number 8 is determination of alkalinity. That is the basic content in water. Okay. So there is no much to tell you about this, because last class also I think so Kirti's group did the experiment on soil acidity. Okay. But here the difference is procedure is of titration. There we did not do any titration. We only checked using the universal indicator. All right. So here what we are doing is we have to determine how acids are influencing the chemical reaction rates. So your water content, all of us are using purified water, well and good. But there are some people who are not using purified water. Normal tap water, what they get is the water which they are consuming. That water sometimes will be chlorinated water, sometimes will be an acidic water, too much of acid content will be there, sometimes too much of basic content will be there. Usually what we drink is all neutralized water. So this is the experiment where we are performing to identify if acid content water is there, how much of acid is present in there. If basic content water is there, then how much of base is present in there. Or if chlorinated water is there, how much of chlorine is present in that particular water. So these are the 3 experiments. Please make the note of procedure, how reagents has to be made. You have to make those proper reagents with that particular gram only. Students, don't go wrong in your composition. If you go wrong in your composition, then it is very difficult for you to make reagent bottles. And then your experiment is completely collapsing. So better you learn the compositions of reagents, what I am giving it to you, so that your procedure is going proper. All right. So the aim is very basic. You are only determining the acidity present in the water, that is acid content present in the water. So what are we doing here? Procedure has 2 steps. Please write the experiment name. Determination of acidity in water. Determination of acidity in water. Please write the experiment name, determination of acidity in water, and directly start with the procedure. But in your record books, you know what all you have to mention. Okay? Procedure goes with 2 steps. Write down. Procedure is with 2 steps. In that procedure A, you are making a standardization of sodium hydroxide solution. You are preparing a standard sodium hydroxide solution, NaOH solution. Preparation or standardization of sodium hydroxide solution. So to prepare this solution, you have to weigh sodium carbonate. Sodium carbonate is the salt given to you. You have to weigh sodium carbonate salt. That is 0.20 grams. 0.20 grams of sodium carbonate. If you are using the same book of observation, morning we took 0.1 gram of magnesium chloride for EDTA. You better change it to 0.1 gram only.
Ma'am,
Okay.
how much, ma'am? EDTA?
There we use, I told you, you take 1 gram of magnesium chloride. Clear?
Yes,
For
ma'am.
ammonium buffer, I
Ma'am.
guess. So don't
Yes,
take
ma'am.
1 gram. 0.1 only is enough. Very little is enough. Okay,
Okay,
change the
ma'am.
reading there.
Okay.
Okay. Now coming to the preparation of NaOH solution, we are weighing 0.20 grams of sodium carbonate, Na2CO3. 0.20 grams of sodium carbonate, Na2CO3. You will weigh this and you will add it to a polyethylene flask of 250 ml. You are weighing 0.20 grams of sodium carbonate and you will add it to 250 ml of conical flask.
$250 ml for what, ma'am?
Conical flask or a beaker, whatever glassware you have, you have to put it in that. Then for the 0.20 grams of sodium carbonate, you will give 100 ml of distilled water. Okay? You are adding 100 ml of distilled water. Okay. Sorry, students. All right. So we are taking 0.20 grams of sodium carbonate. For this, we are adding 100 ml of distilled water and we are dissolving sodium carbonate into distilled water. Okay? Sodium carbonate is dissolved in distilled water. Now, in total, we have 100 ml of distilled water. Sorry, 100 ml of the solution. Okay? That is 0.20 grams is dissolved in 100 ml of distilled water you have in your beaker. To this particular solution, you are adding methyl orange. Students, mention methyl orange is an indicator. Okay. So for this particular solution of sodium carbonate plus distilled water, we are adding methyl orange, which is an indicator. So we'll be adding 2 to 3 drops of methyl orange. 2 to 5 drops. 2 to 5 drops of methyl orange is added to the solution. And then you will titrate it against hydrochloric acid. So in your burette, you will be having HCl. One normal HCl will be there in your burette. So the solution of sodium carbonate plus distilled water with 2 to 5 drops of methyl orange present in your beaker will be titrated against one normal HCl present in your burette. Got it?
Yes, ma'am.
Yes, ma'am.
Okay. Then you have to do calculation here. Weight of sodium carbonate into grams weight of sodium carbonate into grams into 1000 divided by equivalent weight of sodium carbonate into HCl, ml of HCl. So weight of sodium carbonate you don't know, okay? But you know grams into 1000. How much grams of sodium carbonate have you taken?
0.2.
So
G- 0.20.
0.20. That is your weight of sodium carbonate. 0.20 into 1000 is your sodium carbonate weight. Divided by equivalent weight of sodium carbonate. 53. Equivalent weight will be given to you. It will be written on the bottle only. It is 53. So whatever answer you are getting, that divided by 53 into how much ml of HCl have you taken? One normal HCl. In a burette, it is a 100 ml burette, means it will be 100 ml of HCl. Okay, let us take 100 ml of burette. So it is 100 ml of HCl. Or if it is 10 ml of burette, means 10 ml of HCl. Depending on the burette reading, how much of HCl you are taking. So that is first part of the procedure. Okay, you will take the burette reading now. Second part is you will take NaOH solution in the beaker. You will take NaOH solution in the beaker. Beaker here is 250 ml of beaker. So in 250 ml of beaker, you are taking NaOH solution.
NaOH.
Okay. Next.
Ma'am, what is the quantity of NaOH, ma'am?
If we take 1 ml pipette, let us take 1 ml of NaOH only. Or if I take 10 ml of pipette, 10 ml of NaOH. Okay, so we'll take 10 ml of NaOH. 10 ml of NaOH into 250 ml of beaker. To that particular NaOH solution, you are adding 100 ml of distilled water to dilute it. Okay, so after diluting it, you are having 10 ml of NaOH, 100 ml of distilled water, dilution of both. You have one solution of NaOH present in your beaker. To that particular solution, you are adding 2 to 5 drops of phenolphthalein. What is phenolphthalein? Phenolphthalein is also an indicator. Okay. One indicator you are using for sodium carbonate, the other indicator you are using for NaOH. So phenolphthalein you are adding for NaOH solution. The moment you add phenolphthalein, what will be the color of the solution?
Colorless.
Pink color.
Pink.
Phenolphthalein is when added to base, it will give you pink color. Phenolphthalein when added to acid will be colorless. Make a note of it. NaOH is a base or an acid?
Base.
Base. Okay. So phenolphthalein when added to base is giving you pink color. So you are adding phenolphthalein, which means the solution turns pink. And that pink color solution you are titrating again against one normal HCl. When you titrate against HCl, the end point should be from pink color to colorless. Same applies to your sodium carbonate also. Orange, methyl orange, if you add, since sodium carbonate is a salt, it will give you orange color only. It has to go to colorless on addition of acid. So from color to colorless, if it is reaching, that is your end point. When it is reaching from color to colorless, the moment it reaches colorless, you have to stop your burette and then you have to take the reading of the burette. Titrations, you know how we are supposed to do. Okay, then you have to do a calculation for the normality of NaOH. Formula for the calculations of normality of NaOH. Please make a note. Normality of NaOH. Normality of NaOH is equal to normality of HCl into normality of NaOH is equal to normality of HCl into volume of HCl divided by
Volume of NaOH.
That will give you normality of NaOH. Okay, so one way you have taken salt, sodium carbonate, and you have diluted in 100 ml distilled water. One procedure A is over. Then you took 10 ml of your NaOH and then you are diluting it into 100 ml of distilled water. Procedure B is over. Now coming to procedure C. where you are taking water sample. Let us take 10 ml of water sample and dilute that sample into 100 ml of distilled water. Same procedure we are following. Okay. So in both procedure A and procedure B, we were titrating against HCl. But in procedure C, you are titrating against NaOH. What NaOH? Standardized NaOH. Now you will get the normal. Normal NaOH should go into your beaker. Okay. Whatever normal of NaOH you will get, that normal of NaOH should go into your burette, not beaker. If I'm going wrong also, you are simply sitting, not correcting. Which means all of you are sleeping. So whatever normal of NaOH you will get the standard form, that normal of NaOH should go into your burette, and you are titrating against what? Against your water sample.
HCl.
So you will take 10 ml of your water sample, add 100 ml of your distilled water, dilute it. For that you are adding.
Ma'am,
Yes?
water sample. Which water sample, ma'am? Is it tap water
Tap
or?
water sample. Tap water only we are providing. We are not providing any other sample.
Okay.
Okay. Then what you will do after diluting? You are adding methyl orange to the solution. Okay, you will add methyl orange. Now, why is it we are not adding phenolphthalein? Why do you think so? Because phenolphthalein is a base. And if you add phenolphthalein to the solution and you are titrating, you are removing, loosening your burette, NaOH will go into your solution. The color will change again. So to avoid that, we are adding methyl orange, not phenolphthalein. Okay. And then you are after adding methyl orange to the solution present in your beaker, you are titrating it against your burette, that is your NaOH. So what is the end point here? End point means it should be the last. You will stop your burette when you are seeing pale orange color solution. When you see pale orange color solution, you will stop your burette. Okay. Now, your methyl orange and your NaOH has mixed. You will have pale orange color solution. You are stopping your burette. After stopping your burette, here you will add 2 to 3 drops of your phenolphthalein. This is like to note the amount of hydroxyl ions being produced in the solution. That will give you hydronium ions being produced. Hydroxyl and hydronium. That is giving you acidity and basicity. Okay. So when you get pale orange color, you are stopping your burette and you are adding phenolphthalein to the solution. Then run the burette. When you run the burette, end point should be red purple color. Purple color, reddish purple color, wine color. Wine color should be the end point. Okay. So that will be your V2. V1 is what? Phenolphthalein end point. When you have stopped your NaOH, whatever reading you have got, of your NaOH, run down from the burette to get you pale orange color. That is your V1 of NaOH. And whatever rundown of NaOH happened to get you red purple color, that is your V2 of NaOH. Please make a note of it when you are doing the titration, because in observation you have to do this. Okay, then observations are there. Volume of NaOH for methyl orange, that is your V1. Volume of NaOH for phenolphthalein, that is your V2. Volume of the solution you have taken, 10 ml. Can you repeat part C once again? Okay, I'm repeating. I'll take 10 ml of my sample into a conical flask of 250 ml and I'm diluting my 10 ml sample with 100 ml of distilled water. After which I will add some 2 to 3 drops or 2 to 5 drops of methyl orange to the solution. And I am titrating it against NaOH present in my burette. When I titrate it against NaOH, my end point should be pale orange color or faint orange color. The moment I see faint orange color in my conical flask or the beaker, I will stop my NaOH rundown. So whatever amount of NaOH I have used to get that pale orange color will be my V1. After which, to the same solution I am adding phenolphthalein. 2 to 5 drops of phenolphthalein I'll be adding to the same solution and I am titrating it against NaOH. So the end point here is reddish purple color. The moment I get reddish purple color, I will stop my NaOH. That will be my V2. Okay. Therefore, my V1 will be my phenolphthalein reading. My V2 will be my V1 will be my methyl orange reading. My V2 will be my phenolphthalein reading. And the amount of sample I have taken is 10 ml. Then a formula is given to you. You have to use the formula and find out. For the usage of formula, you have to write V2 into normality of NaOH, which you have taken from here, into 50 and 1000, which are constant, divided by your 10 ml. If you know the procedure, calculations are very easy. That will give you the acidity present in the water sample. Got it, students?
Ma'am, can you repeat the formula?
Formula is acidity of water sample is equal to V2 into normality of NaOH into 50 into 1000 divided by 10 ml. Did you understand?
Yes, ma'am.
So likewise we are doing for basicity also, that is alkalinity. Okay, so here you have to do first observation and then you have to go for standardization. You will be doing 3 titrations here. One is, that is your 8th experiment, students. If you were coming here to college today, it would have been better.
Can we come tomorrow?
Tomorrow we have online class. It's because some of you had to go to some far places, they kept this. If I ask them to bring you, like if I ask you to come next Sunday, will it be possible for all of you?
Yes, ma'am.
Yes, ma'am.
For only these titrations?
Yes, ma'am.
Okay, how many of you can come? Please come next Sunday. Because by next Sunday, all this theory will be done. You can come here and start your titrations immediately. Clear?
Okay.
Yeah.
Okay, ma'am.
So at
Next
least you will
Sunday.
have an idea of what is the end point, what is the reading and all that, instead of directly going for the exam.
Yes, ma'am.
Okay. Next Sunday, you please be here. All right. Now here are some observations. Some weighing should be done in your eighth experiment. Okay. First is we are using a weighing bottle here. One weighing bottle will be used. All right. So you have to take the weight of the weighing bottle. Okay. Please write the observation. 1 second, I'll come. Okay. So you have to check the mass of weighing bottle. So please write down. Mass of weighing bottle is equal to M1. Sunday you are all doing all those things. You will come here and you will start off. Next, mass of weighing bottle plus sodium carbonate. How much of sodium carbonate you will add? Please write that in the bracket. 0.26 grams. So to the weighing bottle, you will add 0.26 grams of sodium carbonate and you will take the weight of it.
Ma'am, can you repeat that?
Huh?
The sodium carbonate, how
Can you
much?
please repeat, ma'am?
0.26 grams. So on a weighing machine or a weighing, digital machine, what weighing balance, what you will do is, you will keep your weighing bottle and you will take the weight. Second, you will keep the weighing bottle and 0.26 grams of, see my hands here, I'm keeping them separately. Weighing bottle and then sodium carbonate separately and then you will weigh. That is your M2. Then you will add your sodium carbonate into the weighing bottle and then you are taking the weight, it is M3. Did you understand? Initially it is an empty weighing bottle. Second is you will take weighing bottle and sodium carbonate weight. Third is you are transferring sodium carbonate into the bottle and taking the weight, that is M3. Then molar mass of sodium carbonate is constant, that is 106 grams per mole. Okay. Now we are preparing the solution for volumetric titrations. All right. I have one request from you all. Can we finish this experiment now and 9th experiment tomorrow morning with the 13th practical also?
Yes, ma'am.
Is it okay for you all?
Problem.
Yes, ma'am.
Ma'am, we were thinking if we finish 12 MEV 12 today and 13 experiments tomorrow, we can take exam next week.
That's not possible for you to write exams next week because tomorrow only one session I'll be taking.
Okay.
All right. So I've told them already because tomorrow afternoon session I cannot take. I have some other work to do here in the college since PU is opening. All right, I'll finish this 8th experiment. 9th I will do tomorrow first. 9th I'll finish.
Yes.
Then that is a full
Yes, ma'am.
stop
Yes,
for
ma'am.
your 12, and then we'll start with the 13th. Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay,
Okay.
ma'am.
Okay, this is a request from you all because I am very tired today.
Okay, ma'am.
Okay, ma'am. No issue.
Sorry, ma'am. Sorry. No problem.
It's okay, no problem.
Sorry for that.
You can make out from my face only. Anyways, now we are preparing sodium carbonate. Okay, to prepare sodium carbonate, we are weighing 0.26 grams of sodium carbonate. Mention preparation of sodium carbonate solution. First reagent is preparation of sodium carbonate solution. Weigh 0.26 grams of sodium carbonate. And dissolve in 100 ml of distilled water. And dissolve it in 100 ml of distilled water. So your sodium carbonate solution is prepared. Shake the solution until the mixture is homogeneous. What is the meaning of homogeneous, students?
No precipitate.
Dissolved.
Completely dissolved. It has to get completely dissolved in the water. Okay, so you are preparing your sodium carbonate solution. You are weighing 0.26 grams of sodium carbonate and you are dissolving in 100 ml of distilled water. And the mixture should be homogeneous, clean, transparent mixture without any PPT. Okay, that is your sodium carbonate is prepared. So first titration will be your normal titration. You are titrating sodium carbonate against your HCl. So in the burette you have HCl. Then in your conical flask you will be having sodium carbonate. So how much of sodium carbonate solution you will take? 20 ml of sodium carbonate in the conical flask and titrate against the HCl. Please make a note of it. So you will have 20 ml of sodium carbonate in the beaker and you are titrating it against your HCl. When you titrate it against a HCl, you should titrate until you reach the end point. The end point is red color. Permanent red color. That is the end point. ನೀವು ತಗೊಳ್ಳಿ ಅದು ತರಕ್ಕೆ ಹೇಳಿ ಅವ್ರಿಗೆ. ಇದು ಮಾಡೋಣ share ಮಾಡಿ. Okay, so you have sodium carbonate solution of 20 ml in your beaker and then you have HCl present in your burette. You are titrating it against your sodium carbonate. How much? Until you reach the red color, permanent red color. Red color is the end point. The moment you get red color, you are stopping your titration. Like this, you will be doing 3 trials. 3 trials should be done. Must and should be done. Okay, understood?
Yes, ma'am.
Yes, ma'am.
Okay. Now next what you are doing is we are titrating against phenolphthalein. Okay. Second titration is the same procedure. Here you will be adding some amount of sodium thiosulfate to the water. So phenolphthalein is added. Third step is you are adding methyl orange. Okay. Same way you will take 60 ml of water sample. Initially for the first procedure you took 20 ml. The second procedure you are taking 60 ml of water sample in the conical flask. Second procedure, estimation with phenolphthalein. Mention that. Okay. So here you will take 60 ml of sample, that is your sodium carbonate solution, and then for that you will be adding 1 drop of, remember, 1 drop of sodium thiosulfate. One drop of sodium thiosulfate. And after adding 1 drop of sodium thiosulfate, you will add 2 to 3 drops of phenolphthalein. Okay. When you add 2 to 3 drops of phenolphthalein to that particular solution of your NaCO3, that is Na2CO3 sodium carbonate, and you are titrating against your HCl. When you add phenolphthalein, you will get pink color. So when you are titrating against HCl, your pink color has to disappear. End point is disappearance of pink color. Disappearance of pink color is the end point. All right. So you are taking, I'm repeating again, estimation with phenolphthalein, 60 ml of your sodium carbonate, 1 drop of your sodium thiosulfate, and 2 to 3 drops of your phenolphthalein. And you are swirling when you are titrating. Swirling means moving your hand. You are swirling when you are titrating, and you will swirl until your pink color disappears. Likewise, three readings should be taken. 3 readings should be taken.
Ma'am, in the conical flask,
Yes,
60 ml of Na2CO3, 1 drop of sodium thiosulfate, 2 to 3 drops of phenolphthalein. That's all, no, ma'am?
that's all.
Okay. Three things.
Okay.
Ma'am,
The moment you add phenolphthalein, you will get pink color solution. When you are, please mute us. When you are titrating it, your pink color will disappear. Likewise, 3 trials should be done. Okay.
ma'am, in conical flask, 60 ml of water sample, right, ma'am?
Yeah, water sample. Not water sample. Yeah, water sample, correct, sorry. It's not sodium carbonate, sorry, water sample. Okay. That is estimation of water sample against phenolphthalein. Likewise, estimation of water sample against methyl orange should be done. So here also you will be taking 60 ml of sample, water sample.
Ma'am, in exam, we can choose any one, no? Choose any one, or should we do all?
What anyone you want, one sample or one titration, is it?
These are three methods, no, of estimating.
3 methods of estimating. Then you have to do calculation of HCl. So we are doing three things. Okay. So see, these are all a little lengthy procedures and so many students are there. So you do not worry about the examination. I will tell the external and I will talk to the external. One method is, anyways, we have to take the alkalinity only. One is also well and good. But yeah, I cannot guarantee about Viva. Experiment performance, that we can do something. But Viva, questions will be asked. So how many experiments are there, including your demo and performing experiments? Please prepare yourself well for the Viva examinations, because Viva questions will be a little difficult than your performing experiments.
Okay, ma'am.
Same procedure has to be repeated what you did in the above. You are taking 60 ml of the sample, 1 drop of sodium thiosulfate solution, and then there you added phenolphthalein, here you are adding methyl orange. And you are titrating it against your HCl until you get red color. So 3 titrations are done for the third step also.
Ma'am, here we have not diluted the water sample.
You have though. I didn't mention that. Same thing, what we did in the phenolphthalein procedure, same procedure should be done here also. We are only changing the indicator.
We just took 60 ml of water sample in the phenolphthalein estimation.
That's what. You don't have to dilute anything. There, sodium carbonate has to be dissolved, no homogeneous mixture. So you are diluting in the first step. You are already having water samples here. What will you dilute for those water samples?
Ma'am, what is the end point, ma'am? What color?
For which one?
The last one, ma'am.
Methyl orange, you should get red color.
Red. Okay.
Previous one is what? Phenolphthalein, disappearance of pink color. Correct?
Yes, ma'am. Disappearance of the color. Pink.
So 3 separate calculations are there.
Ma'am, while titrating, how many ml we have to leave in one stitch?
You cannot leave 1 ml, you have to leave drop wise. Burettes are always let go, run down and drop wise. While you are loosening your burette knob, you are swirling. Why is it we are swirling? For the homogeneous mixture, it should mix properly. And one, if you just simply loosen your knob and leave off, you will have too much of rundown of HCl. That will give you a wrong reading. You should always give a drop-wise rundown of your burette sample, so that you will get a proper reading. Never you should leave in mLs. Did you get that?
Okay, ma'am. Okay, ma'am.
All right. So this much you know, you understood, you know the procedure. When you are coming next Sunday to the college for the performance of these titrations, then we can perform and calculate this. Here, instead of simply
Yes,
reading
ma'am.
out some, sorry,
Yes, ma'am.
instead of simply giving some readings and then calculating as a rough, we'll do the titration of this and then we'll write the proper readings only. But see to it, you are coming next week. How many of you can come? Please come next Sunday.
Okay, ma'am.
Okay? All right. So here I'll stop my class for today. I ask your excuse. Please don't mind. Meet you tomorrow with the 9th experiment and then we'll start with 13.
Ma'am,
Some confusion was there. So
Yeah.
in the morning, I was being logged out of the system. First experiment and last experiment only I was able to view. If you have the recorded video, can you share it with me, ma'am, please?
I don't. If I get the video, I will definitely share with you. But you can ask your other friends also. They must be have. They will get it. Okay.
Okay, ma'am.
So,
Ma'am, someone is recording the
yeah,
class.
somebody
Tell
is
them to
recording.
share in the group.
Whoever is recording, if you can share it in the group, it will be well and good. So that others. Deependra is recording, is it?
No, ma'am. It is recording by that Dr. Hema Marini, madam.
Okay, so if Hema Malini madam is recording, then we can ask her only to share it in the group.
Yes, yes.
Okay, thank you, ma'am.
Okay, so with this I have done 8 experiments. 9th experiment I'll be doing tomorrow morning, and then we'll start with the 13th practicals. Clear?
Ma'am, can you repeat the performance experiments, the numbers?
Okay. See, demo experiments out of 10 are only 3, 6, and 10.
3, 5, 6, and 10, ma'am.
3, 6, and 10.
Okay, ma'am.
And the remaining all are performance experiments.
Okay, thank you, ma'am.
All right. Okay.
Okay, thank you, ma'am.
Right. Meet you tomorrow morning in
Ma'am,
9:36.
Okay, 9:30. Okay. Thank you, ma'am.
Yeah,
Okay.
thank you, ma'am. Bye.
Thank you, ma'am. Take care.
Thank you, ma'am.
Thank you, ma'am.